Hello students, so today we are going to continue the chapter by understanding a few symbols that are used to make an electric circuit. The first one is an electric cell, which provides the electric potential in the circuit. The next one is a battery, which consists of many cells put together. So as you can see, this is a single cell and many single cells when connected together. The negative is connected to the positive, so it does not mismatch. So positive negative, then positive negative. So when two or more cells are connected together, then it becomes a battery. So a single cell and a battery which is consisting of many cells. So there is a difference between these two, don't get confused. The next one is a bulb, which can be drawn either like this or this. Then we have two devices which we are going to talk about, which are very important. First one is an emitter, which measures the electric current flowing in the circuit. Yesterday we talked about electric current over here like this. So the electric current is flowing through the whole circuit, and emitter is a device which measures the electric current, and we are going to connect it in the circuit. Next is a voltmeter. As it suggests, it defines or it measures the potential difference across the two ends of the conductor. So suppose we have connected a conductor in an electric circuit, and we need to measure the potential difference across the two ends of the conductor. So what we do, we connect this voltmeter across the 2 points of the conductor with the help of simple wires. I will show you how we are going to connect it. The next is a closed circuit and an open circuit with the help of a key. So a key is a device which works like a switch, which can be connected in the circuit, and the next is the same, a switch. So again there is a difference between the two. A key, which is given by this symbol, and a switch, which is given by this symbol. So there is a difference between the two. Once again, you have to draw the symbols according to the ones asked in the question. So let's see what a question looks like. Simply drawing an electric circuit. So this type of questions are asked in the board examinations for 2 or 1.5 marks, along with the other questions as well. So the combined together can be of 3 marks or 5 marks. So the first question is, draw an electric circuit consisting of a bulb, a conductor AB. So you have to draw a conductor AB, a cell, not a battery, a cell, and a key, along with ammeter and voltmeter across AB. So how do you approach this? First you draw a conductor AB. So we have connected a conductor, which can be a metal component, anything. So conductor AB, and as I said, we need to measure the potential difference. So the voltmeter has to be connected across AB as it is given in the question. So AB is connected over here, and we have attached a voltmeter with the help of two connecting wires on the two ends of the conductor. So we have connected AB, a conductor, and used a voltmeter across AB. Next it is said consisting of a bulb. So we connected a bulb. Now it is not necessary that you connect a bulb over here. It is not mentioned in the question. So you can draw the bulb over here as well. It's fine. So bulb can be made on either side of the connecting wires like this. The next is a cell. So we drew a cell, not a battery, a cell. And a key. Once again a key, not a switch. And finally, ammeter. Now ammeter is a device which measures the current. So current is not just flowing in either AB or the electric bulb. It is flowing through the whole circuit. Current is not flowing just through AB or the bulb. So you don't need to connect the ammeter over here. It can be connected either over here or along with the bulb. Anywhere it can be connected, but the reading from the ammeter, the meter will show a reading which can be anywhere. It can be connected anywhere on the circuit except along with the voltmeter. So you cannot connect an ammeter over here. You have to connect it along with a battery, a conductor, or the bulb, not with the voltmeter. It will give a wrong reading, which we do not want. So the ammeter is to be connected in between, anywhere on the circuit, over here, here, or here. It is fine. Now moving on, this type of simple questions are asked in the examinations. Now we will talk about some practical problems which are related to electric current, which we studied yesterday. The formula for electric current, remember that, and the formula for potential difference. But today we are only going to talk about electric current. So the question is, a current of 150 milliamperes flows through a circuit in 2 minutes. Find the amount of charge flowing through the circuit. So moving forward, first of all, as I always teach you, write all the values. So the first current I, starting with the solution, current I is given as 150 milliamperes. Next is the time is given as 2 minutes. Find the amount of charge. So you need the total charge flowing through the circuit, which we do not have. Applying the formula for electric current, I is equal to Q upon T. Putting the value of I, 150. But if you remember, I said the answer has to be in amperes, and this current I is in milliamperes. So first we will have to connect it in amperes. Now this is the same process as we studied last year in the motion chapter in 9th standard, if you remember. Millimeters into meters and meters into kilometers, it is the same process. So converting milliamperes into amperes, so we are moving from a smaller value to a higher value. So 150 milliamperes to amperes divided by 1000, or I can write 150 into 10 raised to minus 3. I repeat once again, we are converting milliamperes into amperes, so we are dividing it by 1000, making it 150 upon 1000, that is 150 into 10 raised to minus 3. Now you can put this value in the equation, so what you get is 150 into 10 raised to minus 3. And remember, you need to find the Q. So Q. But once again, time is in minutes. As you remember, we talked yesterday that time is in seconds. Charges are in coulombs and current is in amperes. So we converted current into amperes from milliamperes, but we also need to convert time into seconds. So 2 minutes into 60 will give me seconds. Now this is a simple case of cross multiplication. Multiplying 150 into 10 raised to minus 3 into 2 into 60 is equal to the total charge flowing in the circuit. Now when you simply multiply it, what you get, the final answer. Therefore Q is equal to 18 coulombs. Current I is equal to Q upon T, converting current milliamperes into amperes, converting time 2 minutes into 60 seconds, and finally you get the answer by simple cross multiplication of the whole value over here. So 150 into 10 raised to minus 3, 2 into 60 is equal to Q. Therefore Q is equal to 18 coulombs. 15 to is a 30. Moving forward, the next question is, a total of 6 into 10 raised to 46 electrons flow through a current carrying conductor when connected to an external supply for 20 seconds. Find the current flowing through the conductor. You can obviously pause the video and read the question once again. And the charge of one electron is given, minus 1.6 into 10 raised to minus 19 coulombs, because we know that electrons are negatively charged and protons are positively charged. So the charge on one electron is given, minus 1.6 into 10 raised to minus 19 coulombs. However, we are not concerned with the minus sign, we only want the charge. So whether it is negative or positive is irrelevant. This is just for our helping purpose. Now why is this given? Because when we apply the formula I is equal to Q upon T, we have to apply this formula once again, where we need to find the total current flowing through the circuit. So we require the charge. However, this is not the charge of one single electron. This is a charge of 6 into 10 raised to 46 electrons. So simply the total charge is N into electrons. That is the total number of electrons multiplied by the charge on one electron. So this becomes 6 into 10 raised to 46 electrons multiplied by the charge on one electron, that is 1.6 into 10 raised to minus 19 coulombs. Simple multiplication of this will give us the total charge flowing through the conductor. So we can leave it or you can multiply it, it's your choice. I'm going to leave it this way and moving forward. So once again we need to find the current. So current I is Q, that is NE, that is 6 into 10 raised to 46 into 1.6 into 10 raised to minus 19 coulombs. upon time taken, which is given 20 seconds. Now no need to convert it now because it is already given in seconds. So you keep the seconds as it is. Now simple cutting of the subs. 2 10s are 20, 2 3s are 6, 3 6s are 18, 3 1s are 3, 4. So what you get is 4.8 upon 10. This 46 10 raised to 46 minus 19. 46 minus 19. What you get is 4.8 upon 10 into 10 raised to 27. So this is the total current flowing in the circuit. Dividing this 10 over here, what you get final answer is minus 1. So current I flowing in the circuit is 4.8 into 10 raised to 26 amperes. That's all for today, class. We will talk about this in the next period.